channel. I am Bhumikavi, currently pursuing my computer science and engineering from Sri Venkateshwara College of Engineering, Bangalore. Today, I am here to explain a topic which is related to the subject data structures and applications. And the subject code is DCS 304. And the topic is a novel active queue management algorithm based on average queue length change rate, and it is a research paper published by IEEE Transactions. As I said, the title of the research paper is a novel queue management algorithm based on average queue length change rate. And this research paper was published by IEEE Transactions, and the author was Chen Zhao. Today, the agenda of this video is to discuss about the abstract, introduction, literature survey, architectural model, methodologies, results, and conclusion related to the topic. Let's discuss about the abstract. The rapid development of information technology has promoted the transformation of traditional networks into intelligent networks. Huge data traffic is generated by various types of traffic services in the intelligent networks, which can easily lead to network congestion, system instability, and other problems. These problems may incur great requirements and pose challenges for queue management algorithms. Most traditional active queue management, which is shortly known as AQM algorithms, judge the congestion level of the network based only on the size of the average queue length while ignoring the network traffic variations. This makes these algorithms difficult to achieve effective improvement of congestion control efficiency. To address this problem, a novel network congestion control algorithm, namely the average queue length and change rate, that is RED, ACRED, is proposed in this paper. AC-RED can better relieve network congestion by reconfiguring the packet loss strategy model based on the average queue length change rate. Let's discuss about the introduction of the topic. Queue management methods elevate congestion by managing the queuing of packets in the buffers of intermediate nodes of the network. Generally speaking, according to different packet loss modes, queue management mechanisms can be divided into two categories. That is, passive queue management, which is shortly known as PQM mechanisms, and active queue management, which is shortly known as AQM mechanisms. Droptail is a typical PQM algorithm which was widely used on the internet because of its simple working principle. But the disadvantages, for example deadlock and full queue of the droptail, make it likely to lead to increased packet loss, increased delay, and reduced utilization of links. Discuss about queue change model. The packet loss strategy is the key factor affecting the performance metrics such as the packet loss rate, delay, and delay jitter, and also the throughput of AQM algorithms. The packet loss strategy for RED and its variants is based on the assumption that the input traffic characteristics do not vary much over time. However, this does not match the traffic characteristics in the real network environment. Therefore, the average queue length change rate is introduced as a new parameter in order to reflect the change of network traffic more realistically. Network congestion. Network congestion in queue management refers to the situation where a network experiences a high volume of data packets, causing delays, packet loss, or even the collapse of network performance. This typically happens when the demand for network resources exceeds the available capacity, creating bottlenecks that slow down the transmission of data. Let us know about the key concepts in queue management for network congestion. The key concepts are as follows: queues in networking congestion control mechanisms, passive queue management, and quality of service, which is shortly known as QoS, and many more. Let us discuss about average queue length change rate. The average queue length change rate in data structures refers to the rate at which the length of a queue, that is the number of elements in the queue, changes over time. This metric is crucial in understanding how efficiently a queue is being used and how fast it processes elements in various contexts such as network traffic operating systems and real-time processing. About the literature survey. Adaptive active queue management algorithms for 5G and IoT. Lopes et al. 2020 proposed a novel adaptive AQM tailored for IoT and 5G environments. Their method dynamically adjusts queue management parameters based on real-time traffic measurements. While the study does not explicitly use the QLCR metric, it highlights the importance of adaptive congestion control mechanisms in handling the high variability in modern network traffic. And the other one is AQM for cloud computing traffic. Zhang and Lin in 2021 developed an AQM algorithm that uses machine learning models to predict future traffic congestion based on queue length changes, among other factors. The algorithm dynamically adjusts the drop probability and thresholds based on the observed trends, showing the potential of integrating real-time queue length change rate information into AQM algorithms. And learning-based AQM algorithms. Zhao et al. In 2022 proposed a learning-based AQM algorithm that monitors real-time queue metrics such as queue length, delay, and packet loss to dynamically adjust its behavior. Although they did not specifically study QLCR, their works shows the importance of monitoring real-time queue fluctuations in designing effective AQMs. Let us discuss about the architectural model. To design an architectural model for a novel active queue management algorithm based on the average queue length change rate, the architecture would encompass several critical components related to queue monitoring, decision making, and packet management, which includes architectural layers, decision making layer, output layer, control and feedback loops, and detailed functional blocks. Let us know about the methodologies. It includes algorithm-based methodology, congestion detection and control logic, simulation methodology, and performance matrices. And let us discuss one of the methodology, that is queue length measurement. It monitors the queue length in real time at the network router or switch. Queue length is measured either in terms of the number of packets or the number of bytes stored in the buffer. Let us know about the results. Queue length performance, that is the average queue length results, AQCR, which is about 40 to 50% lower queue length than red, and AQCR, which is 20 to 30%, it is lower queue length than pi. Codel maintains comparable queue lengths but is more sensitive to parameter tuning, and it also includes throughput performance, responsiveness to congestion, latency, and delay performance. Here are some references. Javed X Tank, K. Shaukat, M.U. Sarwar, T.M. Alam, I.A. Hamid, and M.A. Salim published a paper called V2X based mobile localization in 3D wireless sensor network, Secured Community Network Volume 2021, which was published in the year February 2021. And H. Adnal Jaber an exponential active queue management method based on random early detection, which was published by J Computer Network Community, Volume 2020, and it was published in the year May 2020. C. Pan, Y. Yang, H. Shi, J. Shi, and R. Kai published a paper called Network Traffic Prediction Incorporating Prior Knowledge for an Intelligent Network Sensors, that was published in the year March 2020. Let us conclude. In this paper, a novel algorithm based on the average queue length change rate called AC-RED has been proposed to improve the efficiency of congestion control. The packet drop strategy of AC-RED is not only dependent on the queue length variation rate but also closely related to the congestion level of the network. Therefore, the proposed method can better stabilize the average queue length and improve the response speed. The proposed algorithm also has disadvantages. Of course, the performance under the multi-bottleneck link needs to be improved. The performance of the throughput also needs to be improved because the poor throughput performance is not only found in the multi-bottleneck link but also in the single bottleneck link. These are where we need to focus on improving in the future. Thank you for watching. Please do like, share and subscribe to my YouTube channel.